Welcome to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and I'm here with my co-host Gary LaRude. In this episode, we're going to continue our coverage of our November 5G, 6G, and IoT issue. And as a reminder, the cover feature was titled The Dual Drive Amplifier, The Next Frontier in Power Amplification, and written by Falcom. And they review their first generation of a 30 gigahertz dual drive power amplifier that's made on a 45 nanometer SOI process. And it's really impressive, achieving 50% power added efficiency with a two-stage amplifier. And this kind of sets a record for a two-stage amplifier on CMOS, so you should check that out. So Gary, what do we have for our product feature?
Well, we have one product feature this month. It's a 3D EM simulation package from CNOS, which is a startup company formed in 2017 by 3 PhDs in physics and math. And their goal in starting the company is to provide an affordable and useful 3D EM simulation tool for small and medium-sized organizations that can't afford the major packages. And they want the platform to be easy to learn, easy to use, particularly for engineers who don't have deep expertise in EM simulation. So kudos to them. I hope they're successful.
So we had two tech briefs. We had 110 gigahertz DC blocks and bias tees from Hyperlabs. And we also had millimeter wave semiconductor production test systems that rival Big Iron ATE from Marvin Test Solutions. And I love that term, Big Iron, used for the bulky systems. And we also had a special guest join us today. Gary talked with David Slack, Director of Engineering at Times Microwave Systems, and they discussed quantum computing basics and why microwave engineers should care. So let's take a look at a clip from that now.
Now, we hear that there's a connection between quantum computing and microwave engineering. How is microwave engineering involved in quantum computing?
Yeah, that's the question for this audience for sure. I'm sure so how do we play in this, right? So the qubits, you can think of the qubits as a microwave resonator, like an LC tank or something like that. Mm-hmm. And you can drive these qubits from a zero state to a one state, to one energy level, 0 or 1, by driving it with a microwave signal. You know, it's a resonant, and you drive it with a signal at that frequency of resonance, and you're going to change the energy level within that resonator. Under this driven condition, the probabilities of being a 1 or a 0 vary sinusoidally with time, and it can be controlled much the way other signals can be controlled. It's important to know that, like other signals, the qubits have a magnitude and a phase relationship. They're complex signals, so it's very, very familiar to the microwave community, these concepts. One of the limiting factors in quantum computing is when you have this resonator under this driven condition, and it's kind of predictable and controlled, that is only able to be maintained for a certain period of time, because with any resonator, there's losses and there's things that affect it that cause it to lose energy and to stop resonating. And that's the limiters here. That is called decorrelation of the qubit, right? When these things become decorrelated, they're no longer predictable, they're no longer controlled, and that's analogous to bit errors in data. So you have computational issues. So the correlation and the control of the qubits is one of the real driving issues behind the technology development.
I love the interviews with Dave. He always is able to put complicated subjects into simple terms, right, Gary?
Yeah, absolutely. I was worried about that one, not understanding it, but he did a great job.
So turning to the news, I saw there were a lot of collaborations that were announced. Anokiwave and Millibox announced a collaboration to facilitate the development of a unique and efficient over-the-air test capability for millimeter wave phased array antennas, and this provides an accurate high-volume testing capability. Millibox has their new test solution that is solving that major challenge to be able to successfully test active antennas in the lab and manufacturing environments at a low cost. Then we also had Skyworks Solutions announce that they will be engaged with MediaTek to offer a complete modem to antenna automotive grade 5G solution. This is a 5G new radio Sky 5A RF front end, and it will accelerate the deployment of cutting-edge protocols across an array of automotive OEM and consumer service offerings. And then finally, we had Keysight Technologies announce that they are working with Altium, and Altium is licensing Keysight's advanced electromagnetic simulation technology, and they'll be developing power analysis solutions for PCB designers. And Keysight and Altium are partnering so they can address this need for hardware engineers that are not really properly trained and power integrity experts, so they'll be able to do that analysis. Gary, what did you see in the news?
So T-Mobile has linked its 2.5 gigahertz spectrum to its U.S. 5G standalone network. Up to this point, the standalone network they have only handled their 600 megahertz spectrum. And initially, at least, those of us on T-Mobile should see reduced latency, maybe better coverage because we don't need the link to the LTE network. And later this year, they plan to begin using carrier aggregation to increase data rates, starting with those who have Samsung Galaxy phones. And then another item, the FCC has conditionally approved 13 automated database systems that will enable service providers to share the 6 gigahertz spectrum for outdoor fixed wireless access services. And this is important because there's 1.2 gigahertz of additional spectrum at 6 gigahertz, and it has 160 megahertz channels, which means 1 gigabit per second data rates. And at 6 gigahertz, the range should be better than millimeter wave lengths can achieve. So it will be interesting to see how this develops.
Yeah, and then turning to events, I think you and I have pretty much finished up our traveling for trade shows this year. We'll be looking forward to early next year for CES, DesignCon, and Mobile World Congress Barcelona, at least in the first couple months. We won't necessarily be attending all three, but we'll certainly cover them. And Electronica is taking place in Germany right now, and that's a really big show, gigantic with hundreds of companies. So you can check out our news for all the announcements around that event because there are several of them.
And before we leave, we want to remind you that our EDICon online presentations are all available to watch on demand. You'll find them at edicononline.com. This was the fourth year of the event. We had 44 presentations with 51 speakers, so a lot of informative and interesting material to choose from, and it's all free. So that wraps up another episode of Frequency Matters. Today's sponsors are RFMW and Times Microwave Systems. As you know, RFMW is a technical distributor focused on RF, microwave, and millimeter wave products, and they represent the leading companies in the industry from antenna to baseband. You can find their line card at rfmw.com. And Times Microwave Systems is a member of the Amphenol North America Military Group, and they are recognized and have been for decades for innovative RF microwave interconnects, including cables and connectors. And you'll find their products at timesmicrowave.com. Well, we'll be back after the U.S. Thanksgiving holiday. Until then, visit microwavejournal.com, where you'll find some cool topics to drop on your family during Thanksgiving dinner, helping avoid any contentious political discussions. Until next time.